In this video, we'll be going over how to find the area between two curves and with respect to x. So we've previously talked about area under a curve and how we can evaluate a definite integral in order to calculate that. So basically now we're going to add to that process by learning how to find the area between two curves. And then just a note here that the term curve is frequently used, but linear functions are part of these examples. So it could be a curve and a line, for instance. So the area between two curves with respect to x can be found by, and we have the definite integral from a to b of f of x minus g of x dx. So this represents our upper function, and this represents our lower function. So we have previously been doing this without even realizing it. When we have been talking about area bounded between a curve and the x-axis, we are really still using this idea between two curves. Because when we think about this, and we look at this graph here, so we have a parabola of f of x equals negative x squared plus 8x minus 7. And we know that we could find the shaded area bounded by that function and the x-axis by evaluating the function from the definite integral from 1 to 7 of the function itself. Now, if we take a look at here, 1 and 7 are our bounds. Our upper function is really the parabola, whereas our lower function is really just the x-axis, so y equals 0. So technically, this region can be considered the area between two curves, where f of x is the upper function and the x-axis, y equals 0, is the lower one. And if we take a look at this and we look at this formula, that would mean that we'd be subtracting 0 in here, which doesn't actually change anything. So we have been doing area between two curves previously. It's just that now in many of these problems, that second curve is going to be something other than the x-axis. So let's take a look at some practice questions. For number 1, we're finding the area bounded by f of x equals 8 minus x squared, and g of x is equal to x squared. So if I take a look at the graph here, let's identify which function is which. So f of x is 8 minus x squared. That's our upside down parabola. And g of x being x squared, that's our upward facing parabola. When we look at this here, we could also, if I zoom in, we can see our points of intersection occur at -2, and +2. All right, so now knowing that we have our bounds set up, we can set up our definite integral. So in order to find the area of that shaded region, it's going to be the integral from -2 to +2 of the upper function, so 8 minus x squared, minus the lower function, dx. Okay. We could simplify this to 8 minus 2x squared dx, and now we can actually evaluate. So if we find the antiderivative, we get 8x minus 2x cubed over 3, and we're going to evaluate that from -2 to 2. And according to the fundamental theorem of calculus, that means we're going to plug in 2, then we're going to plug in -2, and we're going to subtract. And when we do this, if we simplify all of this, we are going to get 64 over 3 as our area between the two curves. All right, let's take a look at number 2. It says, write but do not solve an integral that would determine the area bounded by f of x equals square root of x and g of x equals x cubed. So let's talk about which function is which. So I'm going to highlight f of x in pink, and I'm going to highlight g of x in blue. And you can see here now that the upper function is the pink one, radical x, the lower function is x cubed. I can also see that my bounds are going to be 0 and 1 because those are those points of intersection. So to find the area, it would be the integral from 0 to 1 of the upper function radical x minus the lower function x cubed dx. Okay, let's do that same idea on number 3. We're writing but not solving an integral that would determine the area bounded by the cube root of x. So in this case, here's our cube root of x function. And g of x, our line negative x plus 2. And then we also have some vertical lines as boundaries, so x equals 2 and x equals 4. So this would be the integral from 2 to 4. The upper function is cube root of x. The lower function is negative x plus 2, and then dx. All right, number 4, find the area bounded by f of x equals e to the x, g of x equals the square root of 9 minus x squared, x equals negative 2, and x equals 0. So sometimes the bounds, or the curves, excuse me, are not, f of x is not always the upper. So if you look in this case, f of x is actually the lower function, whereas g of x, this is a semicircle here, is the upper function. So in order to find the area here, the bounds are negative 2 and 0, right? The problem gives us that. The upper function is radical 9 minus x squared minus the lower function dx. So in order to evaluate this, I'm going to use my calculator for this one. Go to Math 9, type in our bounds of negative 2 and 0, and then I'm going to type in my function. So 9 minus x squared minus e to the x. And to 3 decimal places, I get 4.655 as my area of that shaded region. All right, let's do one last one here, and this one's going to be just a little bit different than the others. So in this problem, we are finding the area of the shaded region as well. So f of x is 2 minus x, so that's our line. G of x equals radical x, so that's our curve here. And we also have y equals 0. So in this case, it's almost like we have a third function. So I'm going to highlight that one in green. So if I zoom in on this picture so that we can really see what we're looking at here, if I look over in this region, I see that the orange function is on top and the green function is on the bottom. But if I look over here, the pink function is on top and the green function is on the bottom. So what that means when it varies is we have to break this section into 2 parts and write 2 separate integrals. That's again because the top function is changing at x equals 1. So in order to compute this, we're going to say that the first section is from 0 to 1, upper function minus lower, and then we're going to add that to the next one from 1 to 2, upper function minus lower, and then we're going to evaluate. So if you look to the right of my screen, you can see that I evaluated each of these integrals in my calculator, and now I'm simply going to add them together. So I'm going to add 0.66 repeating, 2.5, and our answer here to 3 decimal places will be 1.166 as our area of that shaded region.